I'm very excited to be here and welcome all of you to this session called Breaking Barriers with MODSIM Approach for Accelerated Innovation. My name is Sri Krishna Srinivasa Chittor, and first of all, I would like to thank my friends at Altair Enterprises, mainly Martinez and Nicholas, for inviting me to be a guest speaker at this really exciting international space convention. I hope you guys are enjoying it so far and continue to do so during the rest of the conference. That said, a little bit of background about myself. As Martinez mentioned, I lead the go to market efforts and enablement efforts for our simulation portfolio, mainly for designers and mainstream users from Dassault Systems. I work from my home office here in Bangalore, in India. And a quick background of myself. I did my undergrad in mechanical engineering here in India and master's in aerospace engineering in the US. And then I worked for nuclear propulsion research at Idaho Nuclear Labs in the US and a couple of startups and eventually ended up in Dassault Systems, wearing multiple hats over the years. Quick background, a little bit off topic. Some of my hobbies include cooking, backpacking, motorcycling, amateur rocketry, listening to music, and playing football. So that's my quick introduction in the interest of time. Uh, I'd also like to give you a short background of the company I work for. We are Dassault Systems. We are a group of 20,000 passionate people spread across 133 countries. We are the 3D experience company. We are driven by the purpose of combining art, science, and technology to deliver engineering design solutions and manufacturing solutions to our 290,000 plus customers and 26 million users across the globe. We'll learn more about the products that we offer and the solution that we offer for the space technology in a minute. To give you a little bit of our background, the name CATIA and SolidWorks and Delmia and Innovia probably resonates very well with most of you. So we are the pioneers in the world of 3D design, which started with CATIA, mainly from the aerospace engineering world, and this started in 1981. And now we have grown massively across multiple domains associated with engineering product development. So Dassault Systems, in very simple term, provides business and people with 3D experience universes to imagine sustainable innovations capable of harmonizing product nature and life. What does that mean? It means we offer end-to-end solution which allow you to innovate faster, cheaper, and better than your competition. We've had quite long-standing relationships in the aerospace and defense industry, and space is definitely one of the key segments that we are involved in, going from ground operations to component and subsystems to satellites and launch vehicles. Um, Without further ado, given the amount of time we have in place, I thought we would use this session to talk about some of the key innovation challenges, especially being faced by a lot of startups who are into satellite design. This would be a good example. Obviously, the solutions that we offer is much beyond satellites in the space industry. But to give you some context, the democratization of space is clearly evidenced by the explosive growth of satellite market. Here, space hardware is available at lower prices, attracting a growing number of customers and leading the creation of startups and spin-offs. There has been an exponential increase in CubeSats launched since 2003, yet the mission success rates averaged only 45% for academia and about 77% industry between 2003 and 2014. And some of the common causes of failure included communication system failures or power issues, deployable issues, or part quality availability, launch schedule pressures, launch delays, and so on. Right. So keeping that context in mind, I thought we would take a look at some definitely not all the challenges, but some of the challenges that you as a satellite maker would face during your innovation process, and especially keeping some of the startups in mind. I come from a mechanical engineering design background. So this session is going to be more focused on the design and manufacturing of the components that go into inside a satellite system. So one of the most common challenges that we have seen with a lot of satellite makers is that they have very siloed set of tools in the engineering design process, and siloed people. What do we mean by that? There are people who are working on completely different tools for creating the CAD models, the 3D designs, the models, the 1D models, and so on. Very few, if not nobody, I would say, use the full power of engineering simulation. And in fact, it's really funny when I mention simulation. Most people think, hey, is this a guidance and navigation control simulation, or is this an avionic simulation? Yes, those are different kinds of simulation, but there's another class of simulation called mechanical engineering simulations. So these are associated with virtually prototyping the parts or virtually mimicking the tests, be it to test the structural integrity of a part, or electromagnetic performance in terms of communication support systems, or it could be thermal management of heat exchangers, or it could be aerodynamics and few other types of simulations. And then there's the last bucket in the engineering design, which is assessing the manufacturability and assessing the right way to manufacture a particular component or an assembly or a system, right? So as of today, these are very siloed, both in terms of people who work on it. Either they are within the same company, or contracted out using completely different set of tools, right? And this makes it very difficult to achieve digital continuity and to streamline the overall development process, because the biggest challenge you have is to get to the market faster, and is to be able to qualify the parts, is to be able to beat the competition. Our solution is called the 3D experience platform. In very simple term, it brings together all the necessary technologies for developing a part, an assembly system or subsystem from scratch, and ensuring that it can be virtually prototyped, virtually tested, virtually managed, and even ensuring that it is manufacturable, and providing really cool marketing and sales material out of it by taking some nice rendering of the product or the simulation, and so on, addressing the needs of design, simulation, manufacturing, product management, where you can actually capture the requirements, and marketing and sales. So it's an end-to-end business development platform that starts all the way from a paper napkin sketch and goes all the way till the life cycle of the product. And this includes all the powerful technologies that have been either developed or acquired by Dassault Systems, starting from CATIA and SolidWorks for 3D modeling, Simulia for simulation, Innovia for data management of the 3D, 2D, and 1D data, and Delmia for manufacturing capabilities. And this 3D experience platform essentially integrates or unifies modeling and simulation worlds together. Um, in the modeling, we are referring to mainly, 1D, 2D, 3D models, and the simulation world, we are referring to, both 1D as well as 2D or 3D simulations to get real insights of how your products are going to perform in action or in a testing environment, even before the products are developed, right? Um, and we've been working with industry leaders for quite some time who have adopted or who are in the process of adopting this MODSIM approach on the 3D experience platform, which they believe as a catalyst for transformation. So some of the key benefits that are being offered by this platform includes digital continuity, where you can start all the way from requirements, design your products, or bring the products from your suppliers. It could be the CAD models in various formats, perform engineering simulations, and come up with assessments, do design exploration, thousands of designs upfront, to minimize the cost of physical testing, to not have to wait until you hear from a qualification test, and so on. Eliminate a lot of rework, and most importantly, it's one single application for multiple phases of product development. Um, let's talk about another facet of this challenge, which is the IT costs, the hardware costs, especially designing a new product and ensuring that it actually performs. Could be quite expensive from an infrastructure standpoint. Space companies face quite significant challenges as they race to get their innovative ideas to the market, securing venture capital, recruiting top-notch staff, ramping up operations. So some of the challenges, especially on the IT side, include lack of IT staff, know-how in order to leverage simulation and accelerate the product lifecycle from concept to liftoff. Cybersecurity is another key concern, providing global access to critical engineering systems or the stakeholders. So the key values that are desired is a low total cost of ownership, faster delivery, no IT management, which is the big portion of the cost, easy to install and deploy applications, secure data, and access anywhere, which is unlimited mobility, right? So Dassault Systems offers our engineering solutions with three elements. Software as a service, on top of the infrastructure and platform. Infrastructure as a service, which means that Dassault Systems manages the virtualization, the servers, the storage, the networking, all of it. So we offer full-blown cloud service, both private and public cloud, for companies across the globe. And then we offer platform as a service, where beyond the infrastructure, this means Dassault manages the operating system, middleware, and the runtime software as required. So this takes off huge amount of time, cost, effort, from a startup standpoint, as we offer these platforms at your service. And if you look at the total cost of ownership, compare it between a on-premise customer-provided IT scenario on the left side and the cloud service on the right, the benefits are pretty straightforward. You have continuous access to state-of-the-art solution for design, simulation, manufacturing, and so on. Lesser IT resources, both in terms of hardware and people, lower hardware and facility requirements, and better cash flows. I think that's the most important part, right? So we've talked about two challenges from a business standpoint. Now let's talk about two challenges from an engineering standpoint. They are very much related, and you will see how it makes sense, how it all comes together, right? The most important challenge that a lot of the people in the aerospace and even automotive industry deal with is lightweighting, right? So for example, if you look at this satellite functional block diagram, which has various subsystems, the most relevant one to this session is structures and mechanisms and thermal controls, right? So here we are talking about thermal analysis of racks and arrays, deployment of folded structures, vibroacoustic analysis, lightweighting, static and dynamic structural analysis to ensure that the vibrations are minimal, and so on, right? So we're going to use the example of lightweighting as a key challenge. So satellite developers strive to minimize the weight, maximize stiffness, reduce cost, and optimize material usage. Today, it is often cost prohibitive to explore optimized parts. It can even be difficult to collaborate across disciplines due to different systems, tools, delays, and so on. and optimization has traditionally required an expert, right? We want to break that barrier. So here the goal is to achieve really high performing yet lightweight designs, and that could be achieved through the concept of generative design. um, Basically, in the past, designers would create shapes based on intuition, expertise, and best practices within the limitations of tool at hand and also the manufacturing constraints. What we have now is a reduced modeling technique where the optimal design is actually generated by the software, based on specification or specific function of the part, which means you as a designer can get an unbiased solution that's also manufacturable. So a generative design allows you to see what your shape wants to naturally be based on its functional requirements or load paths. And this is just one of the examples for me to introduce the concept of MODSIM. So MODSIM is basically unification of design, simulation, and optimization in a single environment. So on one hand you have modeling, and on the other hand you have simulation. So right now they are kind of siloed. Either the companies, especially the startups, they contract it or they don't even do simulation. The workaround is they either over design a product, or they rely on experience from some of the senior or previous engineers, which is okay, but you need to capture that experience and also break these barriers. That's where the MODSIM approach comes into picture, where you have design and simulation and design exploration in one single environment. Let's take a look at this example a little bit deeper. Right. Here are three versions of a satellite bracket design. Each meets the necessary structural requirements. However, the legacy or the baseline design that you're seeing on the left-hand side weighs about 414 grams. Now, we used a generative design solution where we're combining design and simulation worlds together, right? And the optimization. So a lighter version is developed that can actually be manufactured with standard machine milling. The weight is obviously reduced by about 22%, but the amount of material that's wasted, uh, it has actually increased. So we call that buy to fly ratio, which, in very simple terms, is the weight of the raw material that's purchased compared to the weight of the final part. And you want this ratio to be as close to one as possible, right? Now, we could take the third approach where we combine design, simulation, and manufacturing. So, if additive manufacturing techniques are also included in our optimization process, then the design can be further optimized. So, the weight savings is now about 45%, and the buy to fly ratio is significantly reduced. So, this bringing of modeling, simulation, manufacturing, all the domains together, that's what we call as MODSIM. So you're not using different software tools, you're using one single application or one single user interface that brings various applications together, and with minimal expertise needed in specific fields. Yes, you need to understand the functional requirements of the product, but you can get up and running. Just like there is a huge democratization era going on in the field of space, we are experiencing a democratization in the field of engineering design software solutions. So this is a classic example where we are putting these really powerful tools in the hands of a designer who just knows, what is the functional requirement of this part. Here is, a success story from Airbus, where they have actually increased the number of users from 120 to up to 500 for this particular application, because now they're putting these powerful tools in the hands of designers, who don't have to have a strong simulation or manufacturing background. They have been able to reduce their buy to fly ratio by about 10 times, and their design development time. And I just showed you one type of simulation, which is structural simulation. We'll talk about electromagnetics in a bit. But overall, their design development time was reduced by a factor of 4. and their weight reduction from 30%, which was from the traditional manufacturing, to about 70% from additive manufacturing. Now, the best part is you're able to virtually do these assessments even before you go on the shop floor, even before you start building a prototype and then testing. So you're able to reduce the number of prototypes built, reduce the cost, speed up the turnaround time from a design standpoint, and you could even reduce the number of subcontractors that are involved, especially if you're a startup who are tight on cash flow. So from a lightweighting standpoint, you can very quickly optimize the satellite structures with the generative design methods using a very intuitive and automated workflow where you can explore thousands of variants and conduct the final structural validation or physical testing based on optimized parts without too many iterations going back and forth between design and physical testing and prototyping. So we talked about two business challenges, one engineering challenge. Let's talk about the other, the elephant in the room, which is communication, right? Typical questions that a mechanical or an electrical engineer is trying to answer during the development of a satellite is the space available to route cables to the antenna? How do we reduce the physical testing to absolute minimum? Will the satellite structure affect the antenna performance, or will the communication systems interface with each other? And that's actually one of the biggest challenges. um, and testing is very costly because there are two levels of testing. There's ground testing, and then there is in-flight testing, which is still pretty expensive, will still not give you exactly what you're looking for. So virtual prototyping, or simulation in simple words, can drastically reduce the effort required and the risks of finding problems late in the design stage. So you're able to identify the issues upfront. So taking the example of communication and detection system performance, so this involves antenna system performance, where you're looking at antenna design, placement, the right location of placement. Yes, of course, satellite is a mature industry. There's a lot of experience, a lot of know-how, but we are coming with all types of innovation in the world of spacecrafts. So that requires you to change the way you look at how you're placing the antenna, because now there is compactification. There's a lot more antennas that are being placed on a given equipment. And then there is antenna array design. That's also a very critical part of this process, followed by microwave and radio frequency component design, co-site interference, which is to ensure that multiple radio systems can coexist without interfering with each other's signal. And then detection system performance, characterized by radar cross section. So you've got all these processes in this place, and Dassault Systems, especially the Simulia brand of Dassault Systems, offers really complete set of electromagnetic solver technology for antenna simulations. So this is also on the 3D Experience platform, where you can go back and forth between design and simulation to make design modifications and update your simulation on the fly to ensure that you get the best design before going to physical testing. You can generate field and current surface current visualization that could show how the satellite geometry affects the antenna performance, and you can come up with strategies to minimize any co-site interferences. There are specialized tools for antenna array design that could allow engineers to quickly estimate, optimize, and validate array performance, both at the cell level and also at the full array level, with a lot of automation that goes behind the scenes. RF interference analysis can be made quite simple, where you can define and simulate radio system coupling performance to analyze results at a glance through the violation matrix. High power communication systems, feed system design can be made easier by divide and conquer approach, where you can split the problem into smaller pieces and using the best solution technology for each part. Last but not the least, we have got specialized tools for filter design and tuning the optimized solutions in shorter time than the generic simulations. So you've got all these really powerful capabilities that are embedded in a design environment, that are embedded in a data management and manufacturing environment, that just gives you, the full spectrum of the product performance even before it is made. You can simulate, explore the design space, visualize, and optimize the overall installed antenna and feeding system performance. And this is one of the biggest advantages, which is you're not only getting engineering KPIs, but you can actually visualize how your product performs up in space even before it is built. So some of the key requirements for a typical communication and detection system would be to develop, reduce the development time, cost of physical testing, improve safety and performance, and reduce risk of failing certification because you have the electromagnetic compliance or EMC that comes into picture. So MODSIM approach on the 3D experience platform offers quite rapid and virtual antenna design and validation tools, where you can place antenna in various locations, assess, and then come up with the most optimal placement without having to even do it on the real prototype. You can minimize the in-flight and ground-based testing. You can ensure the performance and reliability of coexisting communication system by minimizing the co-site interference, and leveraging high accuracy simulations. You could reduce the risk of failing certification tests, which could put you back in time, effort, and money. Um, to sum up, we've just talked about few of the challenges. There's a lot more, but in the interest of time, some of the key innovation challenges that could be addressed with the ModSim approach on 3D experience platform includes accelerated innovation from idea to first to launch, by breaking the silos and innovating on one single platform, quick deployment, scalability, and optimized total cost of ownership offered with a cloud solution. We also offer on-premise, so you have the flexibility, minimize satellite weight without compromising the performance, and reduce the physical testing costs quite significantly. And last but not the least, significantly enhance communication and detection system reliability. So these are some of the key takeaways for you guys. Thank you so much for your time. And with that, I wrap up my session.